Hello, students. Welcome to the new video lecture. In this series of these videos, we'll be talking about data structure. So in this video specifically, we will see the introduction to data structure. Data structure is a fundamental and building block concept in computer science. It is a very important concept. The good knowledge of data structure is very important to design good and effective softwares. So we actually will see what data structure is and how to implement data structures in this video. So many of time we have seen in our programming classes that all the computer programs that we have been writing in our programming 1 and programming 2 classes, all the softwares, application programs that we have here, they actually take input, they take the data from the user to process something to produce the output and the result. During the execution of the program, the computer program or the application, they actually need to store the data temporarily into the computer memory. Now, the organization and the storage of data into the computer memory is very important. Why it is important? Because it actually impact on the speed of the program and also impact on the efficiency of the program. We already know what is efficiency in our previous lectures, that the efficiency refers to the time complexity and the space complexity. So what does that mean is the way that the program organize and store the data into the computer memory impact on the speed of our program, impact on the usage of the memory of the computer's memory, right? So what actually is this data is that we are going to give the input to the program is some facts and figures like integer values, some characters, some strings, something that we are going to give the input to the program, and obviously based on that the computer is going to store that data into memory and going to perform some operations on that and generate the results on that. So each program must decide how to store this data, because the storage is very important. As I said, the choice of storing the data, that how the program is going to store the data, influence the program at almost every level of the execution, the memory requirements, and the debugging, that how we are going to maintain our program, how we are going to troubleshoot our program, debug our program. All right. Now, since we are talking about the data structures, and we say that the data structure is organizing and storing the data into the memory. One way of organizing and storing the data into the memory where we are already familiar with is called the data type, right? We already know this is data type. And the data type, actually whatever the data we are going to give to the computer is classified into the data types. For example, characters, float, integer, whatever is the data type that we are going to give. Now, the data type basically is a domain of allowed values, that what values are allowed. For example, integer can have positive and negative whole numbers. The character can have the ASCII codes. The float has the decimal values. So it has a domain of the allowed values as well as set of operations on those values. Like, for example, you can add integers, you can subtract integers, you can multiply them. I mean, such type of the operations. Whenever you perform a wrong operation, the compiler actually generates a syntax error. For example, if you have characters X, Y, and Z, you have defined them character, and if you try to multiply these two characters and want to store the result into another character variable, you will get a syntax error over here. The compiler will obviously going to give the error. The reason is this character data type does not allow this multiplication operation, right? So as an example, for example, the Boolean data type has the domain values which are only two, which is either true or false. And the operations that we can perform over here is the logical AND operation, logical OR operation, or equal operations. Similarly, the character, the set of allowed value is the ASCII characters, right? We know the ASCII characters. So all the ASCII characters can be stored into the character data type. And we can equate them. I mean, we can assign them, we can come check the greater than, less than value, and so on. These operations are allowed. So for the integers, if the data type is integer, we can have a minimum value and the maximum value. Maximum integer value and the minimum integer value, depending on how many bytes this integer takes. If it is a 2 bytes, then it takes 2 to the power, I mean, starting from 32,000, negative 32,000 to the positive 32,000. If it is 4 byte, then I mean, it varies according to that. And the operations that we can perform over here is all the numeric operations, which are basically the arithmetic operation that we can perform, or we can check whether two integer values are equal or not. So this is the know-how about the data type. We already know what is the data type, is the singular value, and then this data type actually can have the domain values. Domain value is the set of all possible allowed values, and the operations as well. So there we have two types of data types. One is called the built-in data type, which are available in most of the programming languages like integer and float. We also call them the primitive data type, and you can also define your own data type, which we call the user-defined data types. Or you can say that it's the group of 2 or more data types that we call. In Java, we can define that as a class. So in a class, if you see the instance variables, which may be of different types, and the group of variables, we call them a class, although the class contains methods and many more things. But right now, we can take the class as a type, and you can always define a variable of type class. Okay. So as I just mentioned, you can either have a single data that we are going to call atomic, or the primitive data type like integer, float, character. These all are the atomic data type or primitive data type. And we also have structured data type. Structured data type is like class, which is actually combination of different data types. Like, for example, name, which is the string, age, which is the integer value or the float value, branch, which is the string value once again. And the combination of these three values is called a class, right? Is called a class. Like we have defined these three instance variable, and we can create a class type or the student type. For example, you are going to say in Java student, for example, std, right? So std is a variable of type student, meaning we are going to have a variable of type, which is the class. And then you can initialize it with a new keyword, new of the student, right? That we already know by calling its constructor, which actually initialize all these three variables to that. Now, each variable, each instance variable, each instance or the type is the individual type is called the component of this whole structured data, right? So structured data is collection of some component data types, or is a collection of, you can say, the primitive data types, right? Okay. So now what a data structure is, a data structure actually is also, you can see it like a data type whose values, when I said the values, the allowed values, the domain values, can be decomposed into set of component values, like we have just seen here, we have seen here. I mean, this is one component, another component, right? Can be decomposed, as well as it may also include another structure as its domain values. What do I mean by this? We shall see it with one example in just a few slides ago. So there are different type of data structures that we have, like, for example, the disjoint set of values, which is the unordered collection, the linear set of values, like we have some sort of list, like in Java we have array list, we have linked list, we have array itself. These are all the linear data structure. The tree data structure, graph data structure, of course, throughout the course, we will be talking about all these type of data structures in detail. Okay, so now when we talk about the data structure or the data type, right? So if this is a data type and I'm now calling it the data structure, it has two things. One is set of allowed operations, right? Allowed operations that you can perform on the data type or this data, which this data structure and the data type holds. And the second thing is the allowed values, domain values, right? Now, this domain value, if it is a data structure, it may be the individual element, and it may have another data structure as well. Like, for example, if I talk about, we already remember the array list, right? Or the array of the objects. For example, if I create this one, student student, array of the student. Let's say, for example, std is equal to new of a student, right? So what does happens is this create an array of the student where every location will hold another structure, which is a class, the object of the student. So right, so it may be the individual element, or it may be this itself another structure, maybe the allowed domain value as well. Okay, now another concept which is called the abstract data type. What do we mean by the abstraction? Abstraction is something we want to hide the details of something, right? And we just want to provide the essentials of something. Let's say, for example, you drive a car, right? So you know how to drive the car, like you know how to, if you put the gear on drive, and you just push the accelerator, the car will start moving forward. And if you want to reverse it, you just need to push the gear handle to the R, to the reverse side, and you push the accelerator, the car will start moving backward. You just know these details, but how actually engine operates, how the engine moves forward and how the engine moves backward, you do not know this detail. So those details are hidden from the driver, but those details are available. The engineers, the automobile engineer knows those details. So the details are hidden from the user. If the details are hidden, we call that abstraction. This is abstract. For me, the detail of the car engine is abstract, but I know how to operate it, how I know how to drive it. So I just know that much of detail. Similarly, if the data type hides something, like for example, you know how to store 165 as an integer, but this is actually being stored in the memory or in the computer operates like this one, you do not know this detail being a user, right? So this is called the abstract data type, when the data type hides the implementation detail. So we call it the abstract data type, or in short, we call it ADTs, right? So it's a simple or structured data type whose implementation details are hidden from the user. So we just need to know how to use these data types. Like for example, we know, I mean, how to use integer, float, and the character and the string in Java, but I do not know the detail how actually Java is going to implement that, right? That's why we call the ADT or abstract data type. So while designing the ADTs, our designer has to deal with two types of questions. Number one is what values are in the domain. So now we are going to talk about the ADTs because we are learning about the data structure. Here we will learn both things. We already know how the abstract data types in different programming languages, but now we shall deal with the abstraction as well, and we shall deal with the implementation as well. So the first thing that we need to know is what are the allowed values and what are the allowed operations. So two things, allowed values and allowed operations. And the second thing is how that data is being represented in the computer memory and how the operations are being implemented on that data. When I say the represented, I mean how they are stored in the memory, right? So these two are the important questions while designing the abstract data types. So now, the abstract data type specification, which is also called the mathematical or the logical view of the data, abstract data, right? So it deals with the what question. What question means, we just have seen the what question here, that what values are allowed and what operations can be performed on this data. If we are able to do so, I mean, then this is the ADT specification or the mathematical view or the logical view of this ADT, abstract data type, that we have already been using in our programming 1 and programming 2. Abstract data type implementation answers the how question. How means how actually you are going to do so, how you are going, this data is being stored in the memory, and how these operations are being carried on this data, right? So that's what is happening here. So now we will deal in this course data structure, we will deal with both types, with both specification and the implementation. Like for example, we already know how to use the array list, we already know how to use the linked list, but now we will see how actually they are being implemented in Java. That is also part of this course. So there are two type of user. One is the user, another one is the implementer. Implementer is actually who is implementing this. User is the user who is using this abstract data type. Like we were the user of the array list class, the linked list class in our programming 2 classes. Now we will be acting as the programmer or the implementer to actually write those classes to implement linked list and the array list in our rest of the course, right? So I hope the idea is clear. What is the abstract data type? Abstract data type is where the implementation detail is hidden. And what is the goal is, we have two type of users. One who is going to use this abstract data type, like we were the user of the abstract data types in the previous programming classes. And the other role is to design the abstract data types, right? That we are going to do in this course. We will be writing our own classes for array list. We'll be writing our own classes for the linked list, our own classes for stack, queues, graphs, and so on, right? So here is the summary that we have discussed in this video. Is we are going to have the abstract data type, which is I'm going to say it as a data structure now. This has a set of allowed operations. It has a set of domain values. These domain values could be some element values like integer, float, double. It could be some other data structure like the objects itself. And then with respect to this, we have three views. One is the specification, the mathematical or the abstract view that we have been looking for. And the other one is how the data is being stored and how this is being implemented, that we will be discussing in this class. So with this, we will be starting our first lecture on designing the array list class that we are going to discuss in the next video lecture. Now, summarizing this, what actually is the relationship of the data structure and the algorithm? Remember, in our last week, we have discussed algorithm and the algorithm complexity in detail. So we know that algorithm is a high-level language which is independent of the description of a step-by-step process of solving a problem that we have seen in our last class, right? So now the data structure is a way to store and organize data in computer so that it can be used effectively. And now the set of algorithms which we will be using to implement an abstract data type is also called a data structure. We are going to refer it to the data structure as well. So what does this mean? We will be having a set of algorithms that we will be using to implement the abstract data types like the linked list, like the array list, like the stack and the queue. All right. So with this, I'm going to stop here. And in the next video, we shall see some implementation detail of the arrays and the array list. Take care. Until then, bye.